Next, we're going to be factoring some special cases involving binomials. Binomials are going to have two terms, so they'll be different from the others we've been factoring that have had three terms. Here's an example of a binomial. 9x squared minus 1. Now there are only going to be 4 different types of binomials that we will be working with. The first type is going to be difference of squares. Now difference of squares implies two things. First, that you have a difference, which is going to be subtraction. So I know I'm going to be looking if I have subtraction to see if it is difference of squares, which this one is. The other thing that it implies is that you are subtracting two squares. So in difference of squares, what we're looking for is subtraction of two perfect squares. And the pattern for difference of squares is that it will look like f squared minus l squared, and it will factor into f plus l times f minus l. In this example, we have 9x squared minus 1. First off, we want to check to see if there's a greatest common factor. In this problem, there's not, so we're going to move on. Since we have a binomial, we're going to notice that we have subtraction of two perfect squares, so we're going to be using difference of squares, which is our first special case. I want to identify the first term. Since first times first is 9x squared, I can figure out what it takes to get times each other to get 9x squared, and so my first term is going to be 3x. The next thing I want to look at is my last times last, which is going to give me 1. So that can help me figure out that my last term is going to be a 1. Then the third thing I'm going to do is follow that pattern and make it f plus l times f minus l. So 9x squared minus 1 will factor into f, which was 3x, plus l, which was 1, times f, which was 3x, minus l, which was also 1. Let's look at our second special case. The second special case is one that's not often taught, and it is going to be the sum of squares. In a sum of squares problem, you're going to notice that you have addition of squares, so the addition of two perfect squares. When you have sum of squares, it looks like f squared plus l squared, and it's going to factor using the complex numbers that we've studied already into f plus li times f minus li. Let's look at an example of that. How about 18x squared plus 50? Well, in 18x squared plus 50, we want to start out by finding a greatest common factor if there is one. Both of these numbers are even, so I'll take out a 2. That 2 goes out in front of the parentheses, and that leaves me 9x squared plus 25. Now I have a binomial in these parentheses, that is the addition of two perfect squares, so I'm going to use that sum of squares pattern. First thing I want to identify is what the f term is going to be. So I notice that f times f is 9x squared, which tells me that f will be 3x. Next I want to find my last term. Noticing that last times last is 25, that tells me that L is 5. Now I can put these into my pattern. So that 18x squared plus 50 will factor into the 2 from the greatest common factor times the parenthesis f plus li, so 3x plus 5i, times the second parenthesis f minus li, or 3x minus 5i. Of course, you can always check your sum and difference of squares by foiling them, and you should end up with the original problem. The next two patterns are going to be sum and difference of cubes. And we'll look at those at the same time. Sum of cubes and difference of